So the last 2 days we did some investigations. We looked at different types of rocks. We looked at the clay and how we could make it bend a little easier by heating it up. We looked at how the glass is made with melted sand. And so today we want to look at kind of what does it have to do with our earthquake so far. So we're going to take a lot of the facts that we got from there. We're going to try to figure out, like, what does a model of a earthquake from the side look like? So first thing we want to do is look at this slide here. It says, based on your previous investigations, what would you expect to be similar about what you would find a couple of miles below the surface and both of these locations at Mount Everest and Ridgecrest? So in class we kind of talked about it for a few minutes, and we agreed that there's probably bedrock underneath both of these. So there's bedrock holding up Mount Everest, and someplace below Ridgecrest, some part of the bedrock cracked to make the earthquake. So here is Ridgecrest in California. So this is like the Pacific Ocean over here. And that's where that earthquake happened that we saw the pictures for, where the ground was kind of pulled up in some areas and pulled apart at others. And the question we want to have here is, how could making a model of an earthquake here, what it looks like at the surface and below the surface, how would making a model of this area help us figure out what happened at Mount Everest? So in class, we had a discussion. We kind of agreed that they're both on land, Mount Everest and this earthquake, and they both had earthquakes. So they're similar in that respect. They're both on land. They both had earthquakes. So maybe if we can figure out what happened in Ridgecrest, it'll help us figure out what happened at Mount Everest. Here is a satellite image of Ridgecrest. So we have some mountains here, more mountains off to the side. The places where you don't see this dark area are valleys, so the areas between the mountains. So we got a valley here, we got a valley over here, probably some down here too. This is before the earthquake. This is a picture after. And what I'm going to do is I'm going to go back and forth between these two pictures, and you're going to see something right about this area where I have the cursor going back and forth right now. Just take a look over in that section. And whoops, I keep doing that, sorry. There we go. So you can see kind of how the picture changes there a little bit. That is because of the earthquake. So you can actually see this change from space. Now if you just looked at it, you wouldn't know there's an earthquake, but if you have before and after pictures, you can see that change there. So we look at where the areas are. So we got Sierra Nevada mountain range off to the left of the earthquake. Indian Wells Valley is where the earthquake happened. The mountains off to the side are the Coso mountain range, and there's another mountain range off even further to the right. We're going to take a look at this section right here, and what we want to do is kind of look at the section not from above, but we want to kind of pull that piece out of the earth and then tilt it so we can see down into the earth. So we want to see a cross section of it. Okay, and you can tell this is about 10 miles across. This is a scale here. So it's about 4 miles across. We're looking at about a 10-mile across range. And just remember that this is what we had happen at Ridgecrest. So here's one of the scientists measuring how much the land went up. And you can tell it's maybe only about a foot high. In other areas, it's probably about 3 feet difference in height. From above, you maybe see this walkway or a path or a road or something. You can see that the land got shifted side to side. And one final picture here again showing how the land went up. And this might be in the same section. Actually, this piece right here might be that piece right there. So it might just be from the other angle. So just wanted to take a look at that. So now I'm going to switch over to just a piece of paper because I want to do a model. So I'm going to kind of walk you through how we did our model in class today. Okay, so here is our piece of paper. And so what we wanted to do was kind of draw as if we were going across that map from left to right. So if you remember in that diagram, on the left-hand side we had some mountains. Then there was a valley. Now the valley wasn't going down. The land, if you look at the picture again, if you go back a little bit, you'll see the place where the earthquake happened and she's standing is relatively flat. And then there was another mountain range there was a small valley, and then one more mountain range. Okay, so that's kind of from the side. Mountains off to the west, earthquake area, mountain range, valley, mountain range again. And we said that these mountains are not just piles of rock, it's actually bedrock. So all these mountains are actually bedrock here, meaning it's just solid rock coming out of the earth. Not pieces, but just solid. We kind of agreed that in the valley, she wasn't standing on bedrock. She was probably on dirt. And so we talked about maybe in this section here, there's probably a layer of sediment, erosion from all these mountains kind of coming into the valley and kind of filling the top layer here with soil. So we'll mark that down as sediment. Okay. Next thing we said was, well, underneath all these mountains, what's holding up this mountain here, here, and here would be more bedrock. So I'm just going to abbreviate this so I don't have to keep writing that. So bedrock is BR. So underneath all this stuff, we've got bedrock holding up all these mountains. Because if there wasn't mountains, it was all just dirt, this heavy mountain rock would just sink down in. We also know that way down here, we've got magma in the mantle. Because it's getting really hot down there. It's molten rock. And from our reading, if we heat up the clay a little bit, it gets softer. And we found out when they were drilling that if we go down, so as we go down deeper and deeper, the temperature rises. And I believe when they got like 7 miles down, it was like 380 some degrees, so 300 plus degrees Fahrenheit, and it increases as we go down. So increasing temperature as we go deeper. 7 miles down, it's like 300 plus degrees until it gets to the magma where it can actually melt it. Which kind of brings up a question. If this is bedrock and it's solid, and this is magma and it's molten, someplace in between, we know that rock gets soft, it can bend and kind of not melt, but kind of get just bendable, I guess, and kind of like the putty did when it got warm. So someplace down here, there's going to be a range of area of rock where it's not solid like the bedrock is, and it's not magma, but it's getting progressively softer as we go down. So this is where we would have softer rock and maybe some creeping where the rock is starting to be pushed around because of the weight above it. So we have creeping rock down here too. One thing we haven't put on our drawing is our earthquake. So I'm going to put that right here. It's kind of in the middle between the two mountain ranges here, so we'll just kind of put a line saying that's our earthquake right there. And we'll label that as EQ for earthquake. And we know from the pictures that I showed you just a few minutes ago that one side went up, one side went down. So the left side, on the west side of the earthquake, is the part that was actually pushed up. The right side of the earthquake is where the land was pushed down. And when you have pushed up and pushed down, that's where we got that like 3 foot difference in height. Okay, so that's our earthquake right there. Now the question is earthquake only at the surface? Or does it go deeper? And so we can kind of think. So the dirt can crack very easily because it's just dirt, and it's not going to make too much effort to break that. But you can take a shovel outside and go break up dirt. So the question is, can an earthquake break all the bedrock underneath it? And if it does break bedrock, how far does it crack it down? So I want to go to a demonstration here. So we'll come back to this model in just a second. Okay, so here I have a piece of insulation, and this is going to kind of represent the bedrock that is underneath this area here. So we're going to pretend that that's like this area right here, from top down going down. And we know that it had the crack at the top, and that one side went up, one side went down. So I'm going to hold down the one side. This will be the side that goes down. This will be the side that goes up. So I'm like literally going to do is just kind of pull this up. So I'm just grabbing underneath it so you can see my fingers underneath. And I'm just going to pull up on it while I'm holding down this side here. So I can make this bend. And you can see I can get my whole hand underneath there now. So I got my whole hand sideways. So I'm up there. Now I'm only bending about 3 inches. That rock had to bend 3 feet. So I'm going to make this bend 3 feet, which is above the camera. So I'm going to pull up on it. So I still got to go higher. And you can see what happened, right? So it gets to a point where it won't bend anymore. It's actually going to break. And you could hear that sound. So this is kind of like an example of an earthquake. So we have one piece of rock, cracks, makes a big noise. That is your earthquake. So now we have to take this and go back to our drawing. So you just saw the insulation break, representing that big piece of bedrock here. So now the question is the earthquake just at the top, or does it go deeper? From that example with the insulation, we know it's got to go deeper. It's not just one little scratch at the top, so it's got to go deeper. Question is, does it go deeper still? And the way to look at that is think of a tray of brownies. And I cut a tray of brownies halfway from the top to the bottom of the tray. And I say take out the piece. You're not going to be able to take out the piece because I haven't cut it all the way through. So the only way for this piece of land to move up at the top is if this whole piece cracks all the way down. Because now I've cut from the top of the brownie all the way to the bottom of the container, and now I can take out a piece of brownie, if you can kind of see that idea there. The last thing I want to think of, so this is our earthquake, and it does break the land all the way down through the bedrock to the mantle. And now this whole piece could be shifted up or down. Same with this side. The last question we had in class was this side here. How big is this piece? Right now we were drawing a picture that was 10 miles from here to here. But how big is this piece of bedrock? Like how far does it go over this way? And then how far does this piece of bedrock go this way? And the last thing we came up with in class was this piece of rock will end when we find another crack. The place where we'll find another crack is where we have an earthquake. So how do we find the next crack? We have to find out where earthquakes happen. When we find out where earthquakes happen over on this side, we'll find a crack going down, and then we'll know that this is one big piece of bedrock. We'll go this way. We'll look for where earthquakes happen on the west side. We'll know that that's where the bedrock will end on that side because that's going to be a new crack. It'll be a new piece of rock here. So that's what we talked about today. Tomorrow we're going to continue on with this model and find out some more stuff.